In addition to predicting the products of displacement reactions, we should also be able to predict the products of combustion reactions. We can recognize combustion reactions because they're simply the reaction of a compound with pure oxygen. So as soon as you see a reaction where one of the reactants is O2, that's a combustion reaction. Turns out these are very, very easy to predict their products. You just have to look at your other reactant, look at each element that it contains, and then that will tell you what your products will be. If your reactant molecule contains hydrogen, that will react with oxygen to form water. Carbon will react to form CO2. Nitrogen will form NO2. Sulfur will form SO2. So most of them look very similar. For a metal, you just have to use charges to figure out what kind of metal oxide it would form. So for instance, if I reacted a sodium metal with oxygen, I would say, well, sodium is +1, oxygen is -2. So if I swap charges, the metal oxide I make would be Na2O. So I just need to use the charges to figure out what metal oxide I would produce. Most of the time, these are what I'm going to see though. Let's look at some examples. Complete and balance the following reactions. Now we know these are combustion reactions, but if we weren't sure, we could recognize it because they both have +O2 there. So for each one, we're just going to look at the elements in my reactant molecule and use that to predict my products. In this one of them is carbon, so one of my products will be CO2. And my phases for combustion reactions are always gas. My other element is hydrogen, so that's going to make H2O. That's it. That's how I predict my products. Now the tricky thing I have to do is balance. So I do like to make a list for these, C, H, and O. So on the reactant side, I have 2 carbons, 3 hydrogens, 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, 3 oxygen, and then I just start fixing them. I always save oxygen for last in combustion reactions. Doesn't really matter which of the others I start with, but I see this odd 3-2 here for the hydrogen, so I'm going to go ahead and try and fix that because otherwise I'll probably mess up my carbons when I do. So since I have an odd thing there, 3-2, I need to basically swap those. So I'll put a 3 over on the product side to get 6 hydrogens and a 2 over here to get 6 hydrogens. So now that my hydrogens match, I also affected my carbons here. So now I have 4. And on the product side, I affected my oxygens. So now I have 3 from the water, 2 from the CO2. I have 5 total. So I'm still going to save the oxygens for last. So let's fix carbon. So we'll put a 4 in front of there. And that also affects my oxygen. So 4 times 2 is 8, plus 3 gives me 11. Now here's where I have to do something kind of funny, not that bad, but the only thing I can put in front of O2 to get 11 is half of 11, or 5.5. So if I put 5.5 there, 5.5 times 2 is 11, and now everything is balanced. I can do that for a moment just to fix it. I can't leave it like that. I need to get rid of that decimal, and to do it, all I do is multiply everything by 2. So if I rewrite this, I would have 4 C2H3 plus 11 oxygen plus 8 CO2 plus 6 waters. So I took each of my coefficients and just multiplied them by 2 so that I wouldn't have any fractions. And now I have that 11 here instead of the 5.5, so that's all good. So predicting the products is easy. Sometimes the balancing takes a little more effort. Let's look at a second example. Once again, I'm just going to go through with each element and think about how it reacts with oxygen. So I have hydrogen. That will produce H2O. I have carbon. That will produce CO2. And I have sulfur. That will produce SO2. Now I'm going to balance. My products are super easy. So I have H, C, S, and O. On the reactant side, I have 1 hydrogen, 1 carbon, 2 sulfurs, 2 oxygens. On the product side, 2 hydrogens, 1 carbon, 1 sulfur, and a total of 5 oxygens. 1 here, plus 2 gives me my 5. So this time it really doesn't matter where I start. So I'm going to start with the hydrogen. So I'll put a 2 here to fix him. Of course, that also affects my carbon and my sulfur. So now I'll fix my carbon here. So I'll put a 2 there. That affects my oxygen, but I'm about to mess that up by affecting my sulfur, so I'm just going to leave that and recount my oxygens in a moment. I fixed my carbon. I need a 4 to fix my sulfurs. Now I can account for all my oxygens. So I have 1 oxygen here, 4 here, and 8 here. So I have 13 oxygens total. So once again, this is going to require a fraction, at least momentarily. So the only thing I can put in front of here that would make this work is 6.5. That will give me my 13. I can do this as a little stopgap. Now to get my final answer, I'm going to take the whole thing, multiply by 2. So now I'll have a 4 here, a 13 here. We'll put a 2 here, 4 in front of my CO2, and an 8 in front of my SO2. So if you have to use a fraction, no problem. Just multiply by 2 to get rid of it at the end. Predicting the products, though, really, really easy. Just think about how it would combine with oxygen. However many reactant atoms you have, just think about how they react with oxygen, and that tells you what your products are. And then you just got to balance.